Research confirms that early mathematics experiences play a more significant role than we once imagined. Studies suggest that specific number competencies in 4-year-olds are strong predictors of 5th grade mathematics success. So what does it look like to provide meaningful mathematical experiences for our youngest learners? Today, we'll explore this question with DeAnn Huinker from UW-Milwaukee and Melissa Hedges from the Milwaukee Public Schools. Welcome back to the podcast, DeAnn and Melissa. You have both been guests previously. It is a pleasure to have both of you back with us again to discuss your new book, Math Trajectories for Young Learners.
Thank you for having us. We're both very excited to be here.
Yes, I concur. Good to see you and be here again.
So DeAnn, I think what I'd like to do is just start with an important grounding question. What's a trajectory?
That's exactly where we need to start, right? So as I think about what are learning trajectories, I always envision them as these roadmaps of children's mathematical development. And what makes them so compelling is that these learning pathways are highly predictable. Like we can see where children are in their learning, and then we can be more intentional in our teaching when we know where they are currently at. But if I kind of think about the development of learning trajectories, they really are based on weaving together insights from research and practice to give us this clear picture of the typical development of children's learning. And as we always think about these learning trajectories, there are 3 main components. The first component is a mathematical goal. This is the big ideas of math that children are learning. For example, counting, subitizing, decomposing shapes. The second component of a learning trajectory are developmental progressions. This is really the heart of a trajectory. And the progression lays out a sequence of distinct levels of thinking and reasoning that grow in mathematical sophistication. And then the third component are activities and tasks that align to and support children's movement along that particular trajectory. Now, it's really important that we point out the learning trajectories that we use in our work with teachers and children were developed by Doug Clements and Julie Sarama. So we have taken their trajectories and worked to make them more usable and applicable for teachers in our area. So what Doug and Julie did is they mapped out children's learning starting at birth when children are just born, 1-year-olds, 2-year-olds. And they mapped it out up till about age 8. And right now, last count, they have about 20 learning trajectories. And they're in different topics like number, operations, geometry, and measurement. And we have to put in a plug. They have a wonderful website. It's learningtrajectories.org. We go there often to learn more about the trajectories and to get ideas for activities and tasks. Now, we're talking about this new book we have on Math Trajectories for Young Children. And in the book, we actually take a deep dive into just 4 of the trajectories. We look at counting, subitizing, composing numbers, and adding and subtracting. So back to your original question, what are they? Learning trajectories are highly predictable roadmaps of children's math learning that we can use to inform and support developmentally appropriate instruction.
That's an incredibly helpful starting point. And I want to ask a follow-up just to get your thinking on the record. I wonder if you have thoughts about how you imagine educators could or should make use of the trajectories.
This is Melissa. I'll pick up with that question. So I'll piggyback on DeAnn's response and thinking around this highly predictable nature of a trajectory as a way to ground my first comment, and that we want to always look at a trajectory as a tool. So it's really meant as an important tool to help us understand where a child is in their thinking right now, and then what those next steps might be to push for some deeper mathematical understanding. So the first thing that when we work with teachers that we like to keep in mind, and one of the things that actually draw teachers to the trajectories is that they're strength-based. So it's not what a child can't do. It's what a child can do right now based off of experience and opportunity that they've had. We also really caution against using our trajectories as a way to kind of pigeonhole kids or rank kids or label kids, because what we know is that as children have more experience and opportunity, they grow and they learn and they advance along that trajectory. So really, it's a tool that's incredibly powerful when in the hands of a teacher that understands how they work, to be able to think about where are the children right now in their classroom and what can they do to advance them. And I think the other point that I would emphasize, other than what moves children along, is experience and opportunity, right? Children are going to be all over on the trajectory that's been our experience, and they're in the same classroom. And it's not that some can't and some won't and some can. It's just some need more experience and some need more opportunity. So it's really opened up the door many ways to view a more equitable approach to mathematics instruction. The other thing that I would say is, and DeAnn and I had big conversations about this when we were first using the trajectories, is do we look at the ages? So the trajectories that Clemens and Sarama developed do have age markers on them. And we were a bit back and forth on, do we use them, do we not, knowing that mathematical growth is meant to be viewed through a developmental lens. So we had them on, and then we had them off, and then we shared them with teachers in many of our projects. And the teachers were like, no, put the ages back on. Trust us, we'll use them well. And so the ages are back onto the trajectories. And what we've noticed is that they really do help us understand how to take either intentional steps forward or intentional steps back, depending on what kids are showing us on that trajectory. The other spot that I would maybe put a plug in for on where we could use a trajectory and what would be an appropriate use for it would be for our special educators out there, and to really start to use them to support clear, measurable IEP goals grounded in a developmental progress. So that's kind of what our rule of thumb would be around a should and shouldn't with the trajectories.
That's really helpful. You mentioned the notion of experiences and opportunities being critical. So I wanted to take perhaps a bit of a detour and talk about what research tells us about the impact of early mathematics experiences, what impact that has on children. I wonder if you could share some of the research that you cite in the book with our listeners.
Sure. This is DeAnn. And in the book, we cite research throughout all of the chapters and aligned to all of the different trajectories. But as we think about our work, there really are a few studies that we anchor in always as we think about children's learning. And the research evidence is really clear that early mathematics matters. The math that children learn in these early years, in pre-kindergarten, kindergarten, first grade. I mean, we're talking 4, 5, 6-year-olds, 7-year-olds, that their math learning is really more important than a lot of people think it is. Okay. So as we think about these kind of anchor studies that we look at, one of the major studies in this area is from Greg Duncan and his colleagues, and there was a study published in 2007. And what they did is they examined data from thousands of children, drawing information from 6 large-scale studies, and they found that the math knowledge and abilities of 4 and 5-year-olds was the strongest predictor of later achievement. I mean, 4 and 5-year-olds, that's just as they're starting school.
Wow.
Yeah. One of the surprising findings was that they found early math knowledge and abilities was a stronger predictor than social emotional skills, stronger than family background, and stronger than family income. That it was the math knowledge that was predictive.
That's incredible.
Yes. A couple other surprising things from this study was that early math was a stronger predictor than early reading. Now, we know reading is really important, and we know reading gets a lot of emphasis in the early grades, but math is a stronger predictor than reading. And then one last thing I'll say about this study is that early math not only predicts later math achievement, it also predicts later reading achievement. So that is always a surprise as we share that information with teachers, that early math seems to matter as much and perhaps more than early reading abilities. There's a couple other studies I'll share with you as well. So there's this body of research that talks about early math is very predictive of later learning. But we're teachers, we're educators. We like to know, well, what math seems to be most important? So there was a study in 2016 that looked at children's math learning in pre-kindergarten 4-year-olds, and then looked at their learning again back in 5th grade. And what was unique about this study is they looked closely at what specific math topics seemed to matter the most. And what they found was that advanced number competencies were the strongest predictors of later achievement. Now, what are advanced number competencies? So these are the 3 that really stood out as being important. One was being able to count a set of objects with cardinality. So in other words, counting things, not just being able to recite a count sequence. No, so not verbal rote counting, but actually counting things, putting those numbers to objects. Another thing that they found was really important was being able to count forward from any number. So if I said, start at 7 and keep counting, start at 23 and keep counting, that was predictive of later learning. And the reason for that is when kids can count forward from a number, it helps them understand the structure of the number system, something we're always working on. And then the third thing that they found as part of advanced number competencies was conceptual subitizing. Now, what that is being able to see a number such as 5 as composed of subgroups, like 5 being composed of 4 and 1 or 3 and 2. So subitizing is being able to see the parts of a number. And that was really important for these 4-year-olds to begin working on for later learning. All right, one more, Mike, that I can share?
Fire away. Yes.
Okay, so this last area of research that I want to share is actually really important as we think about the work of teachers in kindergarten and 1st grade in particular. So what these researchers did is they looked at children's learning at the beginning of kindergarten and then at the end of 1st grade. So wow, think of the math kids learn from 5, 6 years old. And they found that these gains in what children can do was more predictive of later achievement than just what knowledge they had coming in. So learning gains, what children do and learn in math in kindergarten and 1st grade, is predictive of their mathematical success up through 3rd grade. And then another study looked even further and said, wait a minute, what they learn in kindergarten and 1st grade even predicts children's math achievement into high school. So there's just a growing body of research and evidence that early math is really important. The math learning of 4-year-olds, 5-year-olds, 6-year-olds, and 7-year-olds really builds this foundation that determines children's mathematical success many years later.
This feels like a really great segue to a conversation about what it means to provide students opportunities for meaningful counting. That feels particularly significant when I heard all of the ideas that you were sharing in the research. I'm wondering if you could talk about the features of a meaningful counting experience. Like if we were to try to break that down and think about what does that mean? What does that look like? What types of experiences count as meaningful when it comes to counting? Could you all talk about that a little bit?
Yeah, that's a great question, Mike. This is Melissa. So I think what's interesting about the idea of meaningful counting is the more DeAnn and I studied the trajectory and spent time working with teachers and students, we came to the conclusion that the counting trajectory in particular is anchored, or a cornerstone of that counting trajectory is really meaningful counting. That once a skill is acquired, and we'll talk a little bit more about meaningful counting, but once that skill is acquired, it just builds and develops as kids grow and have more experience with number and quantity. So when we think about meaningful counting, the phrase that we like to use is that numbers represent quantity. And it's just not that kids are saying numbers out loud, is that when they say 5, they know what 5 means. They know how many that is. They can connect it to a context, that it has they can go grab 5 of something. They might know that 5 is bigger than 2, or that 10 is bigger than 5. So they start to really play with this idea of quantity. In specifically, when we're talking about kids engaging in meaningful counting, there's really key skills and understandings that we're looking and watching for as children count. The first one, DeAnn already alluded to, is this idea of cardinality. So when I count how many I have, 1, 2, 3, 4, 5, if that's the size of my set, when someone asks me how many is it, I can say 5 without needing to go back and count. So I can hold that quantity. Another one is stable count sequence. So we used to call it rote count sequence. And again, DeAnn referenced the idea that really when we're asking kids to count, we're asking more than just saying numbers. So we think about the stability and the confidence in their counting. One of the pieces that we've started to really watch very carefully and think carefully about with our children as we're watching many of them count is their ability to organize. So it's not the job of the teacher to organize the counter, to tell the child how to lay out the counters. It really is the work of the child because it brings to bear counting, saying the numbers, maintaining cardinality, as well as sets them up and sets us up to see where they at with that one-to-one correspondence. So can they organize a set of counters in such a way that allows them to say one number, one touch, one object? And then as they continue to coordinate those skills, are they able to say back and hold on to the idea of quantity? So the other ideas that we like to consider, mostly because they're embedded in the trajectory and we've seen them become incredibly important as we work with children, is the idea of producing a set. So when I ask a child, can you give me 5? They give me 5. Or are they able to stop when they get to 5? Do they keep counting? Do they pick up a handful of counters and dump it in my hand? So all of those things are what we're looking for as we're thinking about the idea of producing a set. And then finally, even for our youngest ones, we really place a fair importance on the idea of representing a count. So can they demonstrate, can they show on paper what they did or how many they have? So we leave with a very rudimentary math sketch. So if they've counted a collection of 5, how would they represent 5 on that paper? What that allows then the teacher to do is to continue to leverage where the trajectory goes, as well as what they know about young children, to bring in meaningful experiences tied to writing numbers, tied to having conversations about numbers. So the kids aren't doing worksheets. They're actually documenting something very important to them, which is this collection of whatever it is that they just counted in a way that makes sense to them. And so I think the other part that I like to talk about when we think about meaningful counting is this idea of hierarchical inclusion. It's that idea that children understand that numbers are nested one within each other, and that each number in the count sequence is exactly one higher than what they said before. So many times our reference with that is with our teachers are those little nesting dolls. So we think about 1, and then we wrap 2 around it, and then we wrap 3 around it. So when we think about the number 3, we're thinking, well, it's actually the quantity of 2 and 1 more. And we see that as a really powerful understanding, in particular, as our children get older, and we ask them not just what is 1 more or 1 less, but what is 10 more or 10 less, that they take that and they extend that in meaningful ways. So again, the idea of meaningful counting, regardless of where we are in the trajectory, it's the idea that numbers represent quantities. And the neat thing about the trajectory is the counting trajectory in particular is that they give us really beautiful markers as to when to watch for these. So we tend to talk about the trajectories as levels. So we'll say at level 6 on our counting trajectory is where we see cardinality first start to kind of show up, where we're starting to look for it. And then we watch that idea of cardinality grow as children get older, as they have more experience and opportunity, and as they work with larger numbers.
That's incredibly helpful. So I think one of the things that really jumped out, and I want to mark this and give you all an opportunity to be a little bit more explicit than you already were, this importance of linking numbers and quantities. And I wonder if you could say a bit more about what you mean, just to make sure that our listeners have a full understanding of why that is so significant.
All right, this is DeAnn. I'll jump in and get started, and Melissa can add on. As we first started to study the learning trajectory, the one thing we noticed was the importance of connecting things to quantity. Even some of the original levels didn't necessarily say quantity, but we anchor our work to developing meaning for our work. And we always think about, even when we're skip counting, it should be done with objects, that we should be able to see skip counting as quantities, not just as words that I'm reciting. So across the trajectory, we put this huge emphasis on always connecting them to items, to things, or to actions and to movements, so that it's not just a word, but that word has some meaning and significance for the child.
I think that takes me to the other bit of language, Melissa, that you said that I want to come back to. You said at one point when you were describing meaningful counting experiences, you said one number, one touch, one object. And I wonder if you could unpack that, particularly one touch for young children and why that feels significant.
It's a great question. And I'll come at this through a lens of watching many, many children count and working with lots and lots of teachers. When children are counting a set, many times they'll look and they'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then however many are in the collection, they'll just say 9 by just looking. And one of the things that we've noticed is that sometimes we need to explicitly give permission to children to do what they need to do with that collection to find out how many. Sometimes they're afraid to touch the items. Sometimes they don't know that they can. And we don't come right out and say, go ahead and touch them. But we just say, gosh, is there another way that you could find out how many? And what we notice are some amazing and interesting ways kids organize their collections. So sometimes to be able to get to that one touch, one number, one object, they'll lay them out in a row. Sometimes they'll lay them out in a circle and they'll mark the one that they started with. Sometimes with our little guys in particular, we like to give them collections where they have to sit things up. So like the little counting bears. So if the bears are lying down, the kids will be very intentional in I set it up and I count it. I set it up and I count it. And they all many times have to be facing the same direction as well. So the kids are very particular about how does this fit into the counting experience. And I would say that's one thing that's been really significant for us in understanding that it really is the work of the child to do that one touch, one object, one count in a way that matters to them. And that a teacher can very easily lay it out and say, find out how many, remember to touch one and tell me the number. Then it's not coming from the child. Then we don't know what they know. So that's been a really, really interesting aspect for us to watch in kids is how are they choosing to go into and enter into counting that. And we look at that as problem solving from our youngest, from our 3-year-olds all the way up is what are you going to do with that pile of stuff in front of you? And that's an authentic problem for them. And it's meaningful.
I think what jumps out about that for me is the structure of what you just described is actually an experience and it's an opportunity to make sense of counting versus what perhaps has typically happened, which is a procedure for counting that we're asking kids to replicate and show us again. And what strikes me is you're advocating for a sense-making opportunity because that's the work of the child, as opposed to, let me show you how to do it, you do it again and show it back to me. But what might be missing is meaning or connection to something that's real. And that sets up what we think might be a house of cards, or at the very least, it has significant implications as you described in the research.
One of the things, Mike, that I would add on that actually I just thought about is when you were talking about the importance of us letting the children figure out how they want to approach that task of organizing their count is it's coming from the child. And Clemens and Sarama talk about the beautiful work about the trajectories that we see that the mathematics comes from the child and we can nurture that along in developmentally appropriate ways. The other idea that popped into my mind is it's kind of a parallel to when our children get older and we want to teach them a way to add and a way to subtract. And I'm going to show you how to do it and you follow my procedure. I'm going to show it, you follow my procedure. We know that that's not best practice either. And so we're really looking at how do we grab onto that idea of number sense and move forward with it in a way that's meaningful with children from as young as 1 and 2 all the way up.
I hope you've enjoyed the first half of our conversation with DeAnn and Melissa as much as I have. We'll release the second half of our conversation on April 9th. This podcast is brought to you by the Math Learning Center and the Meyer Math Foundation, dedicated to inspiring and enabling all individuals to discover and develop their mathematical confidence and ability.